2, and 4, 3. The part that can be a little bit frustrating, which is given a table or a set of points, you are expected to make an equation. So I'm going to give you tables. See? Tables. I'm going to give you tables, or I'll give you a set of points. And you have to tell me the equation that models it. Because every table is linear or nonlinear. So there is an equation that can model it. Linear equations, remember for linear, you have the change in y and change in x is constant. So that's called delta. That little triangle, that's delta, which means change. Because think about Delta Airline, you're changing your location. So change in y and change in x is constant. Okay, change in y and change in x is constant. Adding or subtracting. Nonlinear would be multiplying or dividing. Okay? So given a table of values, you have linear equations look like this. Y equals, if you remember from the front page, y is equal to mx plus b. I said all lines are represented. All linear lines are represented like that. Nonlinear, nope. Total different process. Okay. Notice what I did. Y equals something times x plus something. That means every line can be represented by this equation. There's a trick. Whatever you're multiplying x by is how the y and x are changing. So put in here change in y over change in x. Whatever they're changing by, and you put it as a ratio, you can make the equation as long as it's linear. And then sometimes you have to plus something. I'll give an example. Given this equation, from the table 0, 0, 1, 5, 2, 10, 3, 15, I want to make an equation that models it. First thing I want to do is check to see if it's linear or not. Plus 5, plus 5, plus 5. Right? 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 Mm-hmm.
Right.
And then this is plus 1, plus 1, plus 1. Yep, that's right. So now if it's linear, then I know that it has to satisfy this equation. And I just have to fill out the equation. So I have change, y equals my change in y over change in x times x. What's my change in y? 5. Over what's my change in x? 1. Y equals 5x. Let's just check it. 5 times 0 is 0. 5 times 1 is 5. Notice I'm putting my x in and making sure that it equals my y. Now I'm putting the 2 in where the x is. 5 times 2, 10. 5 times 3, 15. That one's done. Nonlinear is a little bit more tricky. By a little, I mean a lot. You have to not give up with nonlinear. Most of the time, you're not going to get it right away. It's going to take a couple guesses. But there's a nice common formulas they have 8th graders use. So, I probably meant multiply and divide here. These are the 3 main formulas that nonlinear looks like. It's either x squared, x cubed, or 2 to the x. My process, and if you look at my little process here, what I always do is check to make sure it's linear. Always, I check to make sure it's linear. If it's not linear, then I'm slightly grumpy because now I know I might not get it right away. Linear will always follow this process. It's always the easiest. Nonlinear, you start at x squared, see if it works. Then you go to x cubed, see if it works. And then you go to 2 to the x. Okay, so then check these. Checking to see if it's linear. That's my process. So plus 1, what's this? Plus 3. Nope, not linear. Right? Plus 5, that stinks. That's not linear. So now I have to try x squared. What's 0 squared?
0.
Okay, that doesn't really count. What's 1 squared? 1. Okay, that works. What's 2 squared? 4. What's 3 squared? 9. Oh, found it. You're not usually that lucky. Found it. Y equals x squared. But it's always that process. Always. You check linear, see if it works, check the x squared, then the x cubed. However, sometimes you want to know what? Sometimes you have to add things too. Yeah. All right, next set. I'm going to check to see if it's linear. So I got plus 1, plus 1, plus 1, plus 1, plus 7. I already know it's nonlinear. Darn it. So now I'm going to check x squared, x cubed, 2 to the x. So I start with x squared. 0 squared, 0. 1 squared, 1. 2 squared, 4. But before you move to the cube, I'm going to ask you to keep the x squared and then see if you can add. So x squared, 2 squared is 4. 4 plus 4 is 8, but that doesn't work. Now cube. 0 cubed, 0. 1 cubed, 1. 2 cubed, 8. 3 cubed, 27. Found it. Y equals x cubed. Okay. Is this linear or nonlinear? That last one. Well, plus 1 all the way around. Plus 1 and then I plus 3. Nope. It's not linear. So now I go to the x squared. What's 0 squared? 0. Now watch what I'm going to do. 0 squared is 0. How do I get to 1?
Plus 1.
Plus 1. Let me try x squared plus 1 before I move on to x cubed. Notice what I did. I said 0 squared, 0. I didn't do that here because 0 squared is 0. I'm doing that here because 0 squared is 0. How do I get to 1? I plus 1. Try it here. What's 1 squared? What's 1 squared? 1. Plus 1, 2. What's 2 squared? 4.
Plus 1.
5.
Ooh.
What's 3 squared?
9.
9
Plus 1.
is 10. So that's my equation. Y equals x squared plus 1. It's difficult, but follow that process. Now notice my plus. Notice the difference between this last one I did, this one, and this one. You have to be able to identify why I plussed 1 there. Notice that here I always had 0, 0. I didn't have to change anything. So when I started with my x squared, well, 0 squared is 0. I didn't have to plus anything. When I started with my x cubed, 0 cubed is 0. I didn't change anything. When I started with my x squared here, because you always start with x squared, 0 squared is 0, but I didn't have a 0. So I say, how do I get to 1? I plussed 1. And then I check. And sometimes that's not going to work, but then you go to x cubed. And you'd say, okay, x cubed, how do I get to 1? All right, so it's all a guess and check. Trust that you might not get the right answer right away. You don't give up with these nonlinears.